Hi guys, this is Miss Raina from C347 here at MacArthur High School. I want to talk to you about free fall concepts. So you should be following along with me on that paper titled Free Fall Concepts Guided Notes. Um, just for future reference, we're going to be using those same three equations that we introduced at the end of the kinematics 1D unit. And what does it mean to be in free fall? Here's what you write. Free fall is what occurs when the only influence is gravity. So the only downward pull, the only influence on you at all is the pull of gravitational force. Usually by the Earth. As long as we're in high school physics, that pull is going to be by the Earth. So what is a force? A force is just that. It can be a push or a pull. Well, if you're being pushed or pulled, then your movement is changing. It can speed you up or slow you down. So this is what can cause an object's velocity to change. In other words, it will cause acceleration. All right, so speaking of acceleration, gravity has a very, very particular acceleration due to gravity. Um, it's experienced by any object, go ahead and fill in that blank, that is freely falling close to the Earth's surface. Here's the value, and the value is always a constant, meaning it's always going to be the same, again, as long as we're in high school physics. Um, Usually in all of these calculations about something that is free falling on the Earth. It's always represented by the symbol G. So again, what's the value of gravity on Earth? You should be jumping up and down right now, answering 9.8 meters per second squared. All right, so the value of acceleration due to gravity is always represented by the letter G. Before we were using a little a for acceleration, which is fine. What I want you to understand now is as long as we're talking about free fall, the little letter a and the symbol, the lowercase g, are going to be interchangeable in those three kinematics equations. So we're going to skip the history section for right now, when the $1,000,000 question is, if I drop a hammer and a feather from the same height, which one is going to hit the ground first? Well, if I'm an astronaut and I go to the moon, there's no air resistance, and guess what? Just like you saw in the video, they hit at exactly the same time. So then, did it matter how much mass they had? And you should be shouting at your computer screen right now, no way. The mass does not affect in any way acceleration due to gravity. So let's go on to the back of your page. What's gravity exactly? It's a force that attracts objects together. And you're going to argue a little bit about that later on in college, but right now in high school physics, let's say that it's due to an object's mass, okay? So on Earth, this is the force that attracts everything to Earth. If you are on your own out in space, then you have your own very attractive force, and it doesn't depend on how cute you are, it depends on how massive you are. The force is always directed what we call down. But down to me is going to be a different direction from down to somebody in Asia or Antarctica or Africa. And so it's really much more accurate to say that it points toward the center of the Earth, just like it does in this picture. So no matter where you are on the Earth, when you point down, usually that's the way that gravity is going. Let's see. So we can kind of say, let's see, just like in letter E, wherever you are in the Earth, all objects are going to fall directly to the ground. But the ground is going to be, that direction that it's falling is going to point toward actually the center of the Earth. Okay, so what about things that are not exactly on the Earth? Because other celestial bodies will feel that same pull. They're just much, much further away. The other difference is they're much more massive than us, so they have their own gravitational pull. So it's definitely smaller than the Earth. Not as small as you or me, but it's not nearly as heavy. So what do you think? Would you expect its gravitational attraction to be weaker or stronger or the same as the Earth's gravity? And if you're jumping up and down right now saying, well, the astronauts feel hardly any of their weight on the moon, then you're right. The moon's acceleration due to gravity is about 1/6 as it is on the Earth. And this is one of these things that's going to come in handy in future problems. So when you need to know acceleration due to gravity on the moon, go ahead and use a sixth of the acceleration due to gravity on the Earth, or 1.63. So here we go with the three equations. These should be at least a little bit familiar by now. We're going to get used to using them in class, okay? So you made it this far. Thank you very much for following along. Please write down any questions you have so we can talk about them in class. Thanks, guys.